my group are primarily working on right now is our search for that primordial gravitational wave signature. I remember having we would discuss amongst the community, oh, who's going to see gravitational waves first, right? Is it going to be LIGO with the black holes, or is it going to be that we see them via their cosmological imprints? Now, LIGO obviously won that contest, but now we're trying to see the early ones. So yeah, the idea is that if we think that the universe underwent this accelerated expansion right at the beginning, and that put in, it's really cool actually, that like the quantum fluctuations of just like sort of empty space, almost empty space time, created the features that then have now grown into us. Like, that's amazing. Okay, but the prediction is that if this accelerated expansion happened and that indeed quantum fluctuations were happening in that space, they should have imprinted these specific kind of irregularities in space, which we talk about, we call tensor perturbations or tensor fluctuations, whatever. They're sort of like they're irregularities in space that aren't sort of symmetric. They're like, you can imagine an irregularity in space with just like a lump, right? That's like, think gravity kind of pulls stuff into. But you can also imagine irregularities that are sort of stretched in one way and squeezed in another way. They're a different type of feature that could have been put in the early universe. The critical thing about these is if they were there, then they would have been put in at the beginning. And then what they would have done is travel through space as gravitational waves. And again, a gravitational wave is space itself sort of stretching and squeezing in one direction, and then stretching and squeezing in the other direction, and back and forth as it sort of propagates, as it travels through space to you, for example. Okay. And if they were there, now they would have by now, if they were put in at the beginning, they would have just died down by now, but they would have left this critical imprint in how light was polarized back when at this image that I look at, so the image that we capture of the universe, the CMB, the cosmic microwave background. It would have left this it would have polarized the light in a particular way, again, because of the squeeze. If space itself was sort of squeezed, then it would give this particular kind of orientation of the light. So what we're doing now is trying to look for this imprint of polarization in the CMB. And I'm so excited right now because we have these new telescopes in Chile that are dedicated to looking for this signal. And they're working now, and they have been on the sky now for the last year or two. And they are right now kind of scanning the sky in Chile with incredible sensitivity, looking exactly for this signal.